Hi, my name is Claire Peters, and this is my candy model of the Piezo1 protein. So the protein has all the way up to quaternary structure. So for primary protein structure, it is a linear amino acid sequence made up of polypeptides, and you can see all the different polypeptides represented by the different color of the gummy worms. Then for secondary structure, it's alpha helices and beta pleated sheets. For alpha helices, here you can see there's ridges and it's curvy, and so that helps with protein folding and stability. And then the beta pleated sheets, it's a different structure but also helps with protein folding and stability. Then for tertiary structure, this is its overall 3D shape. For the Piezo1 protein, it's crucial for its function as a mechanosensitive ion channel. And then for its quaternary structure, here it is, and it has it's trimeric or homotrimeric, which means that it's 3 identical subunits. And it also has this central pore module. As for my protein, I chose to show it as a ion channel. So this is mainly found in the plasma membrane. So just imagine this being implanted in the plasma membrane, and these caps open and close to allow ions to flow through. The types of cells that contain the Piezo1 protein are mechanosensitive cells, such as red blood cells, and these ion channels act as sensors for mechanical forces such as pressure and stretch. It's an ion channel as it detects mechanical stimuli and converts them into cellular responses. It facilitates the movement of ions across the membrane. It also regulates calcium influx into the cell, which plays a critical role in red blood cell deformability, touch sensation, and cell volume regulation. A functional Piezo1 protein impacts bone and epithelial homeostasis, neural and vascular development, normal red blood cell function, and immunoregulation. And showing the amino acid side chain, normal is arginine, so you see that it has these guanidinium groups. Right here, it has the 3 nitrogens. This is a positively charged polar and hydrophilic amino acid, and these guanidinium group helps form multiple hydrogen bonds and electrostatic interactions. So now my mutated protein. So this changes from arginine to histidine, and I will show histidine here. So histidine is a neural, polar, and hydrophilic amino acid, and it has this imatazole ring, which allows it to act as a protein donor or acceptor in hydrogen bonding, and it also has hydrogen pi interactions and with other aromatic amino acids. So here, this is a mutation change from arginine to histidine in the amino acid position 2456 in the protein sequence. I chose to add it as changing the cap. Even though this wouldn't actually happen in the protein, I chose to show it because it has a gain of function. This mutation has a gain of function, which prolongs channel opening, leading to the excessive calcium entry into red blood cells, causing elevated intracellular calcium to activate channels that increase potassium efflux. So they basically will stay open longer and allow more ions to come into the cell. So a change from the arginine to histidine in this protein will alter the distribution of charge. Although they are both polar, arginine has a much higher pKa and forms stronger electrostatic interactions. So since histidine easily switches from positively charged to neutral depending on the pH, it is more pH sensitive than arginine, which leads to an increased ion flow through channels. A mutation in Piezo1 can cause hereditary xerocytosis, which is a blood disorder that causes dehydrated and misshaped red blood cells. Those who have it may experience jaundice, gallstones, mild anemia, and an increased risk of forming blood clots. So 3 limitations that I thought with my protein model was that it was hard to show the complexity of the protein, just because it is so detailed. So just by candy, it's hard to show the complexity of it. And it was also hard to truly see the 3 identical subunits of the quaternary structure. And then my third limitation is that it was hard to implement all the protein structures into the quaternary structure. So implementing the alpha helices, the beta pleated sheets, to actually see all of that demonstrated in the quaternary structure. But I hope that y'all learned a little something about the Piezo1 protein, and thank you so much.